In this video, we're going to be talking about solving inequalities. Now let's start with a really simple one. Let's start with y plus 5 is greater than 9. This looks just like one of those equations that we were solving in previous videos. The only difference is we don't have an equal sign anymore. We actually have a greater than sign in this case. We solve these equations pretty much the same way for the most part. There's going to be one exception that we'll talk about later. But for now, we want to get y by itself. Y is our unknown, and we want to get y by itself. The way that we do this, since 5 is being added to y, we're going to subtract 5 from both sides of the inequality now. Y plus 5 minus 5, the plus 5 and the minus 5 cancel, and we just get a y by itself on the left side. We keep the greater sign a greater sign, and we have 9 minus 5 on the right side of the equation, which of course is 4. And that is the solution to this inequality. As long as y is greater than 4, this inequality is satisfied. What that means is pick any number bigger than 4. For example, pick 7. Y equals 7. If we plugged 7 into this inequality, y equals 7 into this inequality, we'd get 7 plus 5, that's 12, is greater than 9. Well, that's true. As long as y is greater than 4, the inequality is satisfied. Now, one way to represent what our solution y is greater than 4 looks like is on a number line. So let's say we have a number line here. We'll say this is y equals 0, 1, 2, 3, 4, and so on. Now, y is greater than 4 is going to be represented by everything to the right of 4 on this number line, because everything to the right of 4 is greater than 4. Now the question is, what happens right there at y equals 4? Well, you'll notice the inequality is just a greater than sign. It's not a greater than or equal sign. So we can't include 4 in this inequality. The way we represent that is by putting an open circle right there at 4 on our number line. Now let's say, for example, we had not y is greater than 4, but y is greater than equal to 4. If that were the case, then the way our number line would look is this circle would be filled in. But as it stands, we didn't have an equal sign, we had just a greater than sign, so this is what our number line looks like. We have a couple ways of representing this mathematically. One way would be called set notation. In set notation, just says you put these fancy squiggle lines, that's a set, and we're going to make the set of all y values, and this vertical line here means such that. So this is the set of all y values such that, and you just copy down your y is greater than 4. That's called set notation. Another way to represent our solution, y is greater than 4, is with interval notation. Now, interval notation is going to be most easily done by looking at our picture of our set here. We have all y values greater than but not equal to 4. The way that we represent that is with a 4 and an infinity in parentheses. This is a set of numbers that goes from 4 all the way to infinity. Now, we didn't include 4 in this set because we used a parenthesis in our interval notation. If we did want to include 4 in our set, what we would do is we would use a closed bracket. So a question that I get a lot is, why did we use a parenthesis with our infinity? Well, we don't actually include infinity. We don't even really know what infinity is, so you can't really include it in a set, I guess. Okay, let's do a slightly harder example. Let's do 3 plus 2x is less than or equal to 25. Let's solve that inequality. Now, it's not too difficult because it's just like solving an equation. Getting x in this case by itself means we're going to subtract 3 from both sides of the inequality. We're left with the 2x on the left side, and 25 minus 3 is 22 on the right side. Now, to get x by itself, we have to divide by a 2. Now we have x by itself, and a less than or equal to 22 divided by 2 is 11. X is less than or equal to 11. Now again, there are two different ways to write this. Set notation would be you draw a little set, and you say all x values such that, with those symbols right there, and you just throw in x is less than or equal to 11. Now on a number line, x is less than or equal to 11 looks something like this. Since we're less than or equal to now, we're going to include 11 in our interval. And on the number line, that's just everything over there. Everything less than or equal to, including the 11. So how do we write this in interval notation? Well, the lowest possible number that x could be would be negative infinity. It's never going to be exactly negative infinity because we don't know what that is, but it can be any number as low as we can come up with. The highest possible number for x is 11. And we're going to include 11 in our interval because of this equal sign. So those are our two notations for our solution to that equation. Now I mentioned earlier that there's one little trick that you have to remember when you're solving inequalities, and here's an example that demonstrates that. Let's say we instead had 2 minus 3x is greater than or equal to, we'll say 15. Okay, so we want to get x by itself, and getting x by itself involves getting rid of this positive 2. To get rid of that 2, we subtract 2 from both sides. That's going to leave us with a negative 3x is greater than or equal to 15 minus 2 is 13. Now, in order to get x by itself, we have to divide, in this case, by a negative 3 to get rid of that multiplication by a negative 3. We're going to do that to both sides of the equation. The thing that we have to remember when solving inequalities is whenever you multiply or divide by a negative number, you have to switch the direction of your inequality. So in this problem that we're doing right here, we just wanted to divide by a negative 3, which is fine. We're left with an x by itself on the left side of the equation. On the right, we have 13 divided by negative 3, which doesn't reduce, so you have negative 13 thirds. But we divided by a negative number, so instead of a greater than or equal sign, we have now a less than or equal sign. And that's going to be our solution. Set notation would be the same as before. We write down all x values such that x is less than or equal to negative 13 thirds. And with interval notation, I'm going to skip drawing the number line this time. You're going to get any x value between negative infinity all the way up to negative 13 thirds. And I'm including the negative 13 thirds, so I put a bracket here on the end of my interval because I have an equal sign in my inequality. So again, these are just two different types of notation, set notation and interval notation. For the most part, you can choose whichever one you like. Sometimes the question will specify which one they want you to use. Here's your quiz for this video. Solve the inequality and write the solution in set notation and interval notation. Here's the inequality. 8 minus 9y is less than or equal to 4 minus 7y. This is slightly more advanced than the inequalities that we solved in this video, but keep in mind this is the same process as solving equations that we did earlier. The only rule that you have to remember is up here. Whenever you multiply or divide by a negative number, you have to switch the direction of the inequality. So there's your quiz. Good luck. I'll see you in class.